Chapter 16 is about oxidation and reduction, and we're going to be covering selected topics. So we're skipping 16.1. In 16.2, some definitions. So we've talked about. Okay, this computer is just behaving very strangely, but it seems to be okay now. It was flashing at us. We've talked about oxidation and what they are in an earlier chapter. I think it was chapter 7. Another definition of oxidation is the gaining of oxygen, and I believe that's where the term oxidation originally came from. When something reacts and gains oxygen, that's an oxidation. Examples of a slow oxidation is rust. Rust is produced by the oxidation of iron. So iron metal reacts with oxygen to form rust. Oxidation can also be a very rapid process. Combining carbon in natural gas with oxygen, so here's methane, natural gas, reacts with oxygen to form carbon dioxide. The carbon now has oxygen associated with it, bonded to it. So the carbon has gained oxygen. This is an oxidation. So oxidation is gaining oxygen. The opposite is reduction. Reduction is losing oxygen. But as we have seen before, redox reactions do not always involve oxygen, and so we need a description, a definition that's broader to include those things that don't involve oxygen. So here, lithium can react with oxygen to form lithium oxide. Lithium can react with chlorine to form lithium chloride. These are both oxidations, and so that's where we use these definitions, which are more broad. Oxidation is the loss of electrons. Reduction is the gain of electrons. And that's where we use the mnemonic oil rig. So oxidation is loss of electrons. Reduction is gain of electrons. When we look at these chemical equations, on the left, in the product side, we just have elements. Those elements do not have any charges. It's a neutral atom and a neutral molecule. But in lithium oxide, this is an ionic compound, and so now those elements have charges. And so the lithium has a positive 1 charge, and the oxygen has a negative 2 charge. And so we see that to go from lithium with no charge to lithium with a positive charge, it must have lost an electron. And so that's oxidation. We see the same thing happening when we form lithium chloride. Lithium again has a positive 1 charge. Chloride has a negative 1 charge. Lithium has gone from no charge to a positive 1 charge. It does that by losing an electron. It has been oxidized. Where there is oxidation, there must be reduction, because in order for one thing to lose an electron, something else must gain the electron. There's no homeless shelter for electrons. They have to be passed off to another element. There's also no, place where you can just go and pick up electrons. They have to come from someone. So if one substance loses electrons, another must gain them. Here we have hydrogen reacting with oxygen to form water. And we see that hydrogen is gaining oxygen, so we say that the hydrogen is oxidized. That makes it the reducing agent, and we've talked about this before. The reducing agent is the one that causes something else to be reduced. Just like a movie agent causes someone else, the movie star, to star in the movie, the agent doesn't do it themselves. They arrange for someone else. So the reducing agent arranges for another element to be reduced. Hydrogen is oxidized. Here, the oxygen is reduced, making it the oxidizing agent. So the oxidizing agent causes the oxidation of another substance. So this should be mostly reviewed. There's oil rig and the summary here. So identifying oxidation and reduction. In each of these reactions, identify the substance being oxidized and the substance being reduced. So let's look at this first one. We've got potassium reacting with chlorine to form potassium chloride. How do you go about figuring this out? Well, see if anything is changing charges, actual ion charges. Yeah.
Shouldn't the number in front of the chlorine gas just be 1?
Yeah, it should. Thank you. Because that's not
Or
balanced.
just no number, but yeah.
It should just be no number. Yep. There, that's better. Well, here we had potassium atoms. What do we have over here?
Potassium ion?
Potassium ions, K plus. And we started with a chlorine molecule that has no charge, and over here we have chloride ions. So the substance being oxidized is losing electrons. Which one lost electrons? The potassium. Potassium. So this one is being oxidized, and the chlorine is being reduced. Okay? Yes?
Do you label what's oxidized or reduced on the product side or the reactant, or do you refer to the element itself?
You refer to the element, but you're labeling the reactant.
Okay.
Because the product, it has already happened. So letter B. Here we've got aluminum metal reacting with tin 2 ion to form aluminum ion and tin metal. This one should be easier to see. The aluminum here had no charge, and over here it's got a positive 3 charge. Does it do that by gaining or losing electrons? Losing. Oxidation is loss of electrons, so the aluminum is being oxidized. The tin is going from +2 to 0. It's being reduced. So there's always one thing that's being oxidized and one thing that's being reduced, at a minimum.
Also, how should when you lose a charge?
Well, aluminum became charged, it lost electrons, and it did that by giving the electrons to tin.
Did it?
Hmm?
How? If aluminum has not been present in the active reaction?
Well, if we can use Lewis theory to explain this. So aluminum has 3 valence electrons because it's in group 3. And, well, it doesn't work so great with tin. Tin's annoying. But what aluminum will do is it will donate these electrons to another element. And when it does that, when it's lost 3 electrons, then it'll have a positive 3 charge, and then it'll have a full valence shell. Because you're peeling off the 3s2, 3p1 electrons, and then underneath the second level is full.
Okay, so for A, how come there's no present, charge that...
Yeah, there's no written charges in here, but we understand that this is an ionic compound because it's a metal and a nonmetal. And so we've learned how to predict the charges on these ions. Metals always form positive ions, nonmetals always form negative ions. Any other questions about those first 2? So letter C. What's being oxidized? Carbon. How do we decide that?
It's on the left.
It's on the left. There does seem to be a pattern there. It is a little silly to think about oxygen being oxidized, right? If we look at carbon dioxide, this is not an ionic compound. And so we can't say that the carbon is +4 and the oxygen's -2 because it isn't. But we can go back to the definition where oxidation is gaining oxygen. Here the carbon had no oxygen, and now the carbon is bonded to 2 oxygens. So the carbon is being oxidized. And then what's left, the only other thing there, is being reduced. So the oxygen's being reduced, the carbon's being oxidized.
So the only way to work with, what's it called, molecular, what were they called?
Molecular compounds? I missed the beginning of your question.
Is that the only way to know which one's oxidized or reduced? There's options.
No, it isn't. No, it isn't. Which leads us into oxidation states. But first, let's look at this. Identify the oxidizing agent and the reducing agent. So what I'm going to do is I'm going to go back to the previous slide because these are the same chemical equations. But now we're looking for agents. So if the potassium is being oxidized and the chlorine is being reduced, the agent is the opposite. Okay? This is the reducing agent because by giving up its electrons, it causes the chlorine to be reduced. So potassium is the reducing agent. That's the red agent. And the other one is not the blue agent, it's the ox agent, the oxidizing agent. Potassium is oxidized, it causes chlorine to be reduced. So this is the reducing agent. Chlorine is reduced, it is causing potassium, the other one, to be oxidized, so it's the oxidizing agent. So in letter B, which one is the oxidizing agent? The tin 2 plus. This is the oxidizing agent. And who is the reducing agent? The aluminum. Al is the red agent. I could like write a spy novel or something here. Here, what's the oxidizing agent? Oxygen is the oxidizing agent. And then carbon is the reducing agent. And then it's a simple concept, but it is so easy to get backwards. The best way to be able to do this is to just be able to talk through it in your head. Oxidation is loss of electrons. Okay, which one is losing electrons? If it's if it's being oxidized, it is the reducing agent. And just talk through it in your head.